Hello everyone, welcome to lesson 7-3, Similarity and Transformations. Let's start the lesson by addressing the vocabulary. Recall that a dilation changes the size of a figure by a scale factor, but does not change the shape of the figure. Since the size is changed, the image and the preimage are not congruent. Complete the graphic organizer. Consider each word on the rating scale and place a check. Write in the appropriate column next to the word. If you do not know the meaning of the word, find the meaning in the glossary or on the internet. Let's start by defining dilation. Do we know it well? Have you heard or seen it? You have no clue what a dilation is? And what does it mean? Well, it means an enlargement or reduction of a figure. Keep in mind, because it's been changed in size, it is not congruent to the preimage. Do you know this well? I think you do. We can check that one off. Scale factor. What is a scale factor? The ratio of the length of a side on a scale model to the same side of the original object. So it's the ratio. How is it going to change? Is it going to be half the size? Is it going to be 4 times larger? It's the ratio. So that's what a scale factor is. And it's a scale factor works on the same unit of measurement. You probably have heard this before. We've worked with it before. Do you know it well? Well, no, that's up to you to check either one. I would say that you have seen it or heard of it, and you are well on your way to knowing it well. Similar figures. We know what similar figures are, and that's what we're going to be discussing here. Similar figures are two figures that are the same shape but may have different sizes. So that's kind of similar to a dilation. They're not congruent, they're simply similar because they are the same shape but may vary in size. I think of a shoe size when I think of this. We can have the same style of shoe but in different sizes. Those are similar, right? They're similar shoes, similar figures. Real world example. A fractal is a geometric image that can be divided into parts that are smaller copies of the whole. The photo at the right is an example of a fractal. So let's see here. There it is. So it's essentially repeating patterns, and they can vary in size. So I can almost see that these areas repeat again and again, and they're getting larger and larger as they go out. Key point. Identify similarity. Two figures are similar if the second can be obtained from the first one by a sequence of transformations and dilations. It makes sense. So we might have to use a translation, rotations, and so on, or increase or decrease the size. Let's look at example 1. Determine if the two triangles are similar by using transformations. Okay, so we would have to see if there is a key factor that would convert this line GI to line DF. And then if we use that same factor with line HG, convert to line ED. And same for the other two lines. Since the orientation of the figures is the same, one of the transformations is a translation. Right, we would just have to move it over. That's a translation. And then we would measure HG, as we mentioned earlier, HG right there is 8, while ED is 4. So it looks like it's 2 to 1. Right, so this one is double the size of this one. If that's true, they should all be 2 to 1. GI, the bottom line, line GI, and line DF fit the pattern. You see how GI is twice the size of DF? And so on, 10 to 5. So they're all 2 over 1, or 2 to 1. Since the ratios are equal, triangle HGI is dilated image is a dilated image of triangle EDF. So the two triangles are similar because a translation and a dilation maps triangle EDF onto triangle HGI. For example 2, we have a similar scenario. Now we have rectangles, and we can see that there has been, one of the transformation has been a rotation counterclockwise by 90 degrees from the point, from the vertex W, right? Counterclockwise. Or if we were going from the smaller image to the larger image, it would be 90 degrees clockwise. Okay, so it just depends if the blue or the green is the pre-image. And then you would measure to see if the ratios all apply, the scale factor. Okay, so first, yeah, it looks like our pre-image is our blue one. We rotate it 90 degrees clockwise on the W vertex, and then dilated, there's a dilation where you can see that it's being increased, okay, and it's being increased proportionally. The ratios are not, actually, it's not quite proportional. And you can see that here. If we look over here, TW line or WT will become line XY, and that's a ratio of 5 to 7, right? TU right there will become YZ, and that's 3 to 4. The ratios are not equal, so the two rectangles are not similar since a dilation did not occur. The dilation did not occur. This did not become this proportionally. Okay, now let's try it. Here we have, for example A, we have two right angle triangles. Now, my first guess is that there is a clear transformation. It's been reflected over the y-axis. Okay, if we were going to go from the blue triangle being our pre-image and our green right angle triangle being our image, we first reflect it and then we dilate it, we enlarge it. Let's see here. On this side, line ST would become line PQ after the transformation. Line ST has 1, 2, 3 squares. Line PQ has 1, 2, 3, 4, 5, 6. So it looks like it doubled. And let's see if this rule applies to our baseline. Line UT is 1, 2, 3, 4, 5. If the rule applies, then line QR should be 10, because if it's 5 here, it should be 10 here. Just the same way it's 3 here, it's 6 here. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we have a factor of 2. It first reflected over the y-axis. This could be our y-axis. And then it doubled. It became double the size. So we can say they are similar. A reflection and a dilation with a scale factor of 2 maps triangle STU onto triangle PQR. Okay, let's try question B. Let's see if these two parallelograms, or they're not parallelograms, they're quadrilaterals, have they're similar, right? Remember, for them to be similar, the ratio of the sides all have to be the same. For example, it looks like, let's go from the small to the large. Over here we have 1, 2, and over here we have 1, 2, 3, which is an increase of 50%, because 50% of 2 is 1. And if we increase it by 1, that's an increase of 50%, correct? So it would be 3. Over here we have 1, 2, 3, 4. An increase of 50% here would be 2 more, right? Because 2 is 50% of 4. So it should be 6 if we do another 50% increase. 1, 2, 3, 4, 5. It's not already, you can tell. Right? It only increased by 1, and over here it increased by 1, but proportionally speaking, over here it increased by more than it did down here. Over here, let's see, 1, 2, 3, 4. Again, it should go up to 6 if we're going to increase it proportionally by 50%. 1, 2, 3, 4, 5. So no, I don't see that we have the ratios of the side lengths are not equal. So we can say they are not similar. The ratio of the side lengths are not equal for all the sides. So, to clarify, similar and congruent are not the same word. Congruent, for a congruent shape, you would have to have the same size, angle, length. But for similar figures, they may have the same shape, but may have different sizes. The sizes of the two figures are related to the scale factor of a dilation, meaning they must be all dimensions or all the side lengths must be proportionally equal. So if the scale factor of the dilation is between 0 and 1, then the dilated figure is smaller than the original. If it's equal to 1, the same size as the original. If it's greater than 1, larger than the original. It makes sense. So here, if it's a fraction, it's smaller. If it's equal to 1, it's the same. If it's greater than 1, it'll be larger. And that's only when we're talking about the scale factor. Okay, let's look at the first example, a real life example when it related to photographs. Ken enlarges the photo shown by a scale factor of 2 for his web page. So a scale factor of 2. This to me means that he's doubling it in size. He then enlarges the web page photo by a scale factor of 1.5 to print. If the original photo is 2 inches by 3 inches, what are the dimensions of the print? Are the enlarged photos similar to the original? So multiply each dimension of the original photo by 2 to find the dimensions of the web page photo, right? We've dilated it, we increased it by a scale factor of 2, which means we doubled it. So in real life, it's 2 inches. We multiply by 2, we get 4. And 3 inches multiplied by 2 is 6. So it went from a 2 by 3 to a 4 by 6. Okay, so the web page photo will be 4 inches by 6 inches. Multiply the dimensions of that photo by 1.5 to find the dimensions of the print. So we're going to multiply it by 1 and then add half. So 4 times 1 is 4, and 4 times a half is 2. So it's 4 plus 2 is 6, and this will go to 9, if that makes sense to you, right? Because you have to multiply 6 times 1, and then 6 times a half. 6 times 1 is 6, and 6 times a half is 3, and together they make 9. So what do we get here? We get 6, and we get 9, just as I mentioned. The printed photo will be 6 inches by 9 inches. All three photos are similar since each enlargement was the result of a dilation. So we used the same scale factor for all the dimensions. And when you do that, then it is a dilation, or it is a similar figure. Okay, last example. An art show offers different size prints of the same painting. So similar, but they're different size. The original print measures 24 by 30 centimeters. I think those are important numbers to write down, so I will write them down. 24 by 30. Okay? A printer enlarges the original by a scale of 1.5. Okay, so times 1.5, just so that we can get the enlarged size, and times 1.5 again. Okay, 24 times 1 is 24. 24 times a half is 12. So that's going to make it 24 plus 12 is 36. Same here, 30 times 1 is 30. And then 30 times a half is 15. And 30 plus 15 is 45. Okay, so there are my new dimensions. 36 by 45. I'll write that down here. 36 and 45. Right? Okay, looks like there's a second transformation or dilation happening. And then enlarges the second image by a factor of 3. What are the dimensions of the largest print? Okay, so by 3. We have to triple this. When I triple 36, I'm going to get 108. And when I triple 45 times 3, oh, that's a very ugly multiplication sign, sorry, times 3, I get 135. Okay, so therefore my new dimensions are 108 centimeters by 135 centimeters. That's a much larger picture. So are both the enlarged prints similar to the original? Yes, they are, because we increased each dimension the same way each time. Over here we increased it by 1.5, and then we increased that by 3 in each dimension. So yes, they are similar. Okay, everybody, here is our guided practice. If you are done the video, please pause, take a look at this practice 1, 2, and 3, and we will begin class with this. See you then, everyone.